Let me know if you can see my screen, please.
We can see it.
Okay, good. All right. Kennedy, can you tell me how to do question 8? We did this yesterday. How did we do question 8? How do we figure out these two missing boxes? Go ahead. Don't be shy.
I,
Say it again.
I don't
Say it again. I could barely hear you.
I can help you.
No, no. I said Kennedy. Your question come in.
No, I said to help her.
Yeah, I know. I say your question come in.
Oh, we got that.
Go ahead.
Why?
I can barely hear you, boy. No, no. Check my volume.
Yeah.
You can hear perfectly? Yeah, this thing is, the volume is at bottom. This. Let me do something. Okay. All right. Let me see if I Bluetooth this, if it could work, if it could be clearer. Okay, good. All right, try talking now, Kennedy.
It was.
Okay, go ahead. All right, that's much better.
Um,
Go ahead.
yeah, I don't know.
You can't remember?
I didn't
This.
get that much notes on this.
Oh, you don't have that much notes on this? That's strange. We did the whole thing. Go ahead, Miss Cooper, help out.
Um, we did y equals -6 pi -4, and then y equals -2, and then bracket -2, and then -4, and then we do y equals 4 minus 4, and then we get y equals 0 for the
Yes.
first box.
Yes. So what we did,
And
go ahead.
I was saying that what we get for the first box was under -2. And then for the second one, it was y equals -2 times, I mean -2x minus 4. And then y equals -2 in bracket 2 minus 4. And then y equals -4 minus 4. And here y equals -8.
Okay, very good. So we basically did was we took y equals 3 over 2, open bracket x plus 2, and we substituted the 2 in for the x, all right? And that's how we got 0. And then we substituted the 2 here in for x, and that's how we got -8. Okay, so that's how we did that. Does that ring a bell?
Okay, thank you.
Kennedy, does that ring a bell?
Yes,
Okay. All right. Next
can I
question.
write this down, please?
Okay, let me write it down properly for you. So
Okay.
what we did was we took the equation. It was we separated the screen into two, and we said, hey, y equals to 3 over 2 x plus 2, and we said that, hey, our x is -2, going to be negative 2 plus 2. Let me know when to continue, um, Miss Reckley.
Oh, you continue. I follow it.
Okay, so y equals to 3 over 2. What is negative 2 plus 2? What is
0.
0? Very good. So it's 0. And then y is equal to negative 3 over 2. Sorry, 3 over 2 times 0 is going to be what?
0.
0.
Bro.
0. So that's how we got to 0 there, okay? And then we did the same thing for the side. But this time we're going to substitute in negative 2. Sorry, give me a moment. Let me allow these persons to come in. All right, welcome to those who are just joining. All right, Conrad, why is your name appearing twice? Or is that just me? Hello, Lionel.
That is cool. When I was trying to come in on my phone and the laptop was saying,
Oh, okay. All right, because one time someone came in as you and it wasn't you. So I just making sure.
"That's
They,
me."
yeah, they use your name.
What?
Yeah, they use your name. That's happened.
So when they was in your name, that means they find out you made Cody.
No, they didn't find your code. They just know your name, but it wasn't your it wasn't written exactly how you would write yours.
Oh, okay.
Yeah. All right. You know who I don't see? I don't see Miss Gardner. All right. Okay. So let's go back. Yeah. So um it's gonna be x plus 2, and this is y is equal to 3 over 2. Now instead of the x, we're gonna put what? Positive 2, right? And so it's gonna be y is equal to 3 over 2. What is excuse me? What is 2 plus 2?
4. 4.
4. And what is 3 times 4?
12.
12. Very good. So it's gonna be 12 over 2. What is 12 over 2? What is 12
I'm
over
so
2?
confused.
Go ahead.
In the first part was negative, and you put it as a positive 2.
Let's go here. The first one, this one was negative 2, so I insert that here. So that's where this one comes, negative right there.
Oh, okay.
And then now this
Thank
one,
you.
this one is positive 2. So I'm putting it in here. Understand? Understand, Kennedy? Kennedy, you're following?
Yes, sir.
Okay. Yeah, so we just put the positive 2 here. 2 plus 2 is 4. What is 12 over 2?
8.
12 over 2. So how do we get the negative 8? I don't understand.
Listen, you do it different from last time.
And how we get How we get negative 8? How we get negative 8? You want to tell me my point was wrong?
Is negative 2x minus 4.
Oh! This is funny.
You forgot to go,
This is funny. No. It's fun. This is so funny. We used the. Of course, I did. I used a different equation. Sorry, I was thinking about the question I did today in class, man. Oh, wow. I'm looking at a 2018 paper. We didn't do 2018 paper. We did 2014. My goodness. Sorry, this is what we did in class today. And I was thinking about this. No, this is wrong. I mean, it's right for the question, but this isn't what we did yesterday. Anyway, let's just finish it. It's gonna be 6. Okay, it's gonna be 6. That's my bad. My apologies. I feel so embarrassed. All right. Sorry about that. For our question last night, we was using. I'm so sorry. Wow, 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 wow.
Don't worry, it was just that's fun to write, but I know why you do it that way.
Yeah. So we use. Sorry. We use y equals negative 2x minus 4. Okay, that's what we use. All right.
So write this one down.
So this is the correct one, but we still do the same. We still do the same. Still do the same working though from yesterday. We still do the same thing. We still substitute. All right. So what we supposed to do? This is the one you're supposed to write down, Miss Raku. So what we supposed to do is we supposed to still split it in half, but this time we're using the equation y equals to negative 2x minus 4. Is it minus 4 or minus? Is it minus 4? Let me see. Yeah, minus 4. So it's gonna be
Can you repeat that?
so it's y equals to negative 2x minus 4,
Minus 4.
and then we substitute the negative 2, right?
Yes.
Minus 4. So y is equal to negative 2 minus
No.
negative 2 is going to be what?
4
Sorry,
minus 4.
negative 2 times negative 2 is going to be positive 4, right?
And then minus
And then y is equal to 0.
yes, sir.
And then y is equal to. That's why I didn't think none of it, because we got 0 the first time.
X minus 4.
Yeah, so this time we substituted. What is it? It's the 2. So minus 4.
2 minus
So
4.
y is equal to
Then y equals negative 4 minus 4.
y is equal to negative 8.
Negative 8.
Yes. Okay, so better than mine.
Mr. D, so what that was you saying?
I was doing another question very similar to it.
But after he had 0 for the first one, I thought, but then
Mhm.
he should have second question. I know what you could be.
Yeah, I was saying that's why I didn't think none of it. I was like, wait, we got 0, so that should be right. And then when I really look carefully, um, it was not so.
Okay.
All right, so that's how we figure out what goes inside it. This is gonna be 0. This is gonna be negative 8. For this one, we graphed it. For this one, we saw that the gradient is simply negative 2, and that's because negative 2 is in front of the x. We saw that. For this one, we actually had to draw in the graph. We had to figure what that graph looks like and everything. So for those who wasn't here, please watch the video to see exactly how we did that. But in the end, we ended up with something like this pretty graph here, right? Um, the y and the x, this line like so, and this line like so. All right. Okay, so that's what we end up with. I got some beautiful notes yesterday from people. They did a very good job. Did a very good job. Honestly, they did a very good job. Um, did a very good job. Some people really did it neatly. All right. Okay, so let's continue. So, all right. So we already finished this question. It's a tough question right now, but we managed to plow through it. Should we do transformation? Should we do transformation? Hmm.
I'm
Hmm.
getting the graph of Mr.
Hmm. Hmm. Or should I go easy with you all tonight? Let's see.
We could do that tomorrow because I forget my graph book.
What do you mean you forget your graph book? How you forget? How you forget that?
Because I leave it somewhere. I leave it
You leave it somewhere?
and I come home well.
Okay, so let's
No,
do.
I leave it somewhere. I leave it.
Okay, let's do the transformation. All right, let's do the transformation. Aye, aye, aye. This is gonna be interesting. But we're gonna attempt it. We're gonna do our best. Okay. All right. Here goes nothing. Go ahead. Okay, no, I can do this when Nancy come because I don't want her to miss it. So let's do the factorization because it shouldn't be too so hard. Let's do the factorization and then hopefully she'll be then here by now and then we could do that transformation. So let's factor out this. Okay. So we want to factorize this completely. All right. So let's look at this question. So it says factorize completely. So the first thing we're gonna do is we're gonna this is for 3 points by the way. Sorry, my bad. My apologies. Sorry. What I should do, since this is here, let me bring this all the way down here so that I have enough space. So we're gonna begin with this first question for the night. Um, on factorization. We should do several examples of this because I don't know if the first one is gonna be enough for you to really get it. So here we have 12 x squared y plus 8 x y squared minus 4y. All right, and we have to factorize that. The first thing we have to find is we have to determine what is going to be the greatest common factor between 12, 8, and 4. Okay, so what is the greatest common factor between 12, 8, and 4? Right, so let's list the factors.
16.
What? Not multiple,
My bad.
factor. Factor. So what are the factors of 12? What are the factors of 12?
1,
So factors
2,
of
1,
12
3,
is going to be what? 1,
4,
2,
2,
3,
3,
4.
4,
Cannot be 5, right?
6,
6. Um, um, can we say 7? No. 8? No.
no,
9? No. 10? No. 11? No. So
12,
12. Very good. Then factors of
1, 2,
8. We're going to be factors of 8.
1,
1
2, 4,
and 8, right?
8,
Then factors of 4.
1, 2,
1, 2,
2,
and 4.
4,
So what is the greatest common factor?
4,
4. 4. Very good. So 4 is the greatest common factor. So the first thing we need to pull out of this thing, excuse me, is 4. Um, what else is common between the 3 terms? 4 is common.
2.
No, not
2
2. No, I'm not talking about the
Why?
fact. Say it again.
Why?
Y, very good. Someone said it.
Awesome.
Y is here, Y is here, and Y is here. Okay, so Y is common. Is X common in all 3 terms?
No, sir.
No. So the only thing we can pull out really is Y. And so the question now is, what can we multiply 4y by to get 12x squared y?
3.
3, but 3, if we just use 3, this will be 12y, but we need 12x squared y.
3 squared.
3, we need 3x squared, right?
Squared.
Because if we get 3x squared, it's going to be 4 times 3, which
Yes,
is 12. And then x squared times y is give us what? 12x squared y, right? So the next one, then the first term is 3x squared. Next, we ask ourselves, what can we multiply by 4y to give us 8x squared y squared? So to give us 8xy squared. Again, what can we multiply by 4y to give us 8x squared?
X squared.
Someone saying it. Go ahead, Kennedy.
X squared.
Say it again.
2x squared.
2 what?
X squared.
2x y.
Squared.
Mm-mm.
Oh, X, Y. Oh.
xy. Y, xy.
Like, the reason why we said it's because it was already a Y here, so.
Exactly. If you have a y here and a y there, that'll give you the y squared, right? And then all you need is the x. Okay. And then 4 times 2 is 8. Okay. So again, 4 times 2 is 8. Y times y is y squared. And then x, we need the x because there's no x out front. Okay. Lionel, are you here? Oh, Lionel. Oh, Lionel. You here? You sure you here? Okay. Okay. Where's your friend? They always wonder. All right. Next up, we're gonna what we need to put to get the negative 4y. What do we need to put?
1.
Negative 1. Okay, negative 1. So that's how we do that factorization problem. All right. Okay, so can we try another one?
Yeah, so.
Okay. So what if I said so try this one on your own. So what if I said what if I said what if I said 3 x y squared plus 9 x squared y plus or minus rather minus 27 xy. Wait, let me just allow this person to come in and I'll let you do it on your own. All right, hello, Miss Maury. So try this on your own. Oh, who's this again? Abigail. Hey, Abigail, I was wondering where you was. So try this one on your own. This one is an example. Try that one on your own. Let me know what you get when you answer it. Anyone done yet? Anyone done?
No.
No? Michaela, what did you get? What was your answer? Hello, Michaela. Don't be shy. Anyone?
I am finished.
So we are not at this example. We're taking pretty long on that. So I'm gonna try it since we're taking so long with this. What is the greatest common? What is the factors of 27? So let's do it. The factors of 27.
1, 3, 9, 27.
1, 3, 9,
9,
27.
27.
I don't know of any other ones. Then we need to figure out the factors of 9. Right? What are the factors of 9?
3,
1,
9,
3 and 9.
9,
And then factors of 3,
1 and 3.
1 and 3. And then, so what is the greatest common factor?
3.
Very good. So the
3.
greatest, thus the greatest common factor the greatest common factor of 27, 9, and 3 is 3. Okay.
You there, Mr. Petit?
All right. Just waiting on you all. So I can move.
Let's say what?
I can move.
Yes, sir.
All right. Okay. Next up, it's gonna be equal to the greatest common factor is 3, right? What else is common in all?
XY.
XY. Very good. XY. Because XY is here, XY is here, and XY is here. Now in order to get 3xy squared, what must I do?
What equals to 9? That plus 3.
So if I just put y here, wouldn't that be right? Because we already have the 3, we already have the x, we need a y squared though. So 3xy times y is going to be 3xy squared. Okay.
But you're trying to get 9 though.
No, the first one.
Oh.
Yeah, the first one. Sorry, the first one. Yeah. So
Mr.
don't.
Petit.
Yes, ma'am.
I think it is y plus 3x minus 9.
Well, let's see. So it's going to be plus. We need 9x squared y. So what we need to do is multiply the 3 by the 3. We already have a x already, so we need to multiply that x by another x. And we already have the y, so we don't need to worry about this y. We already have it. Minus 3 times 9 is 27. And that's it.
Sounds right?
That's what you said?
Yes, sir.
Well, then you are right.
Another example, please. One more.
All right. This one just for Kennedy. All right. Can I move it?
Yes, sir.
Give me 1 minute.
Okay.
Yes.
60 seconds on the clock. Make sure I bring that home run. Right, Conrad?
Finish.
All right, good. Okay, so let's see who's waiting. I thought someone was in. Okay, yeah, Nateo. All right, welcome, Mr. Nateo. Um, so let's do another one. So, so let's do something like, say, if we have 15 x squared plus x plus y squared. So factorize that completely for me, please. Factorize that completely.
Hey, not gonna lie to you, Kennedy, you a ugly black bitch, and Mr. Cooper, you got a fat ass. Not gonna lie to you.
Okay. Okay. Sorry about that. My apologies. Sometimes they creep in. And like I say, Ken, what's his name? Conrad. They use the same name, so it's hard for me to tell.
So they just get the link.
I don't know.
Someone gotta be doing some weird stuff.
Exactly. That's all I can say.
You just see Big Deal still in his class there, empty.
Yeah. We coming down to the end of the year, so some people saying that they're gonna wait until um, next semester, and next week is the last week of classes, so we coming down to the end. Okay,
One more week.
one more week. One more week.
I think I got my answer.
All right, you got it. What you got?
But
You scared?
no, take the risk.
Take the risk. Go ahead.
Mm, okay, but common factor 5, right?
You got 5 for the common factor. The greatest common factor, okay.
Factors. Okay, hold on. Let me see before I say anything. Okay. Okay. I got 5x y,
Okay.
and then in bracket I got 3x plus 1 plus 5y.
Okay.
I don't know.
Anyone got the same thing?
Yes, I agree with it.
You agree? Okay.
Oh,
Okay.
yay! I get it right. Wait, I don't know. I don't know
You
yet.
don't
I
know.
don't know yet. Bye bye.
You don't know yet, but at least someone agree with you. All right. So let's look at the factors, right? So factors of 15. It's gonna be 1, 3, 5, and 15. Factors of 5 is gonna be 1 and 5. Then factors of 25 is gonna be what? 1,
1 and wait,
5,
wait, 1 and 5.
and 25. I can't think of any
One
other.
five.
So the greatest common factor is definitely 5. So that's good. Okay, so let's keep that down. Shantavia. Okay. Shantavia, that's you? Shantavia Forbes, is that you?
Mm-hmm.
No, that's Shantavia.
Wait, what they keep coming in this for?
Yeah.
That sounds like a mine.
Okay, that's Shantavia.
Bro, trying to play it off.
They coming as your name too, Connor.
Yeah, they came in as his name too.
Everyone, I will catch them. Hey, what I get tell them again? Hey, Mr. Petit, I believe for a second.
All right. It's crazy, man. I don't understand. All right. So, all right. So, straight fill. So we got that the
We doing
greatest.
the next one after this.
No, I think this will be the last one of this. So it's gonna be equal to um 5xy open bracket um 3. Sorry, let me use a different color. Open bracket 3x. And the reason why it's 3x is because if we say 5 times 3, we get 15. If we say x times x, we get x squared. And then y is going to be y. Okay, so that's good. Then 5xy times 1 is going to give us 5xy. So it's going to be plus 1. And then we're trying to get 25 here. Sorry. We're trying to get 25 here. And so it's going to be plus, well, 5 times 5 is going to give us 25. So we need to put 5 here. We have x here. And we have x here. So we don't need to put in no x. We have a y already. The only thing we need is another y because it's y squared. So it's going to be y. All right, and that's our answer. And that means that it's correctly, and anyone else who said it was correct. Is that clear? Is that clear? I can't hear you all if you're talking. Can you all hear me? Hello, can you hear me? Can you hear me, Miss Cooper? Can you?
Yes.
Yes. Okay. All right. Good. Okay. All right. So, Miss Cooper, you want to do another one? You didn't. You don't understand it?
Yes, I just practice one more.
We'll practice one more. All right. Let's do another one then. Okay. So, since you all already know the easy stuff, what if we have 49? Um, okay. So try that one.
Well, this question escalated quickly.
Yes. Try that. 30 seconds.
I want to be cool to put the answer just to put it in there.
Mm-hmm.
So for the factor, I got 7xy.
7xy. All right. I like that you noticed it was 7. Okay. How did you know it's 7?
Because I could see it.
You could see it.
To see it.
You could see it. Okay. You know your multiples of 7, right? All of them are multiples of 7, isn't it? What times 7 is going to
Yes.
give us 49?
7,
7. What times 7 is going to give us 14?
2,
And what times 7 gives us 28?
4.
Very good. Someone knows their multiplication tables. All right. Good. All right. So you're right with that. Definitely,
Yep.
definitely it is going to be 7, right? Let me see what it says now. All right, that's Nancy. Nancy, that's you? Speak fast.
Yes, sir.
All right. Okay, that's definitely Nancy. All right. I don't think we should be expected no more. persons. Usually that's it. All right, good. So, Nancy, we're trying to factorize this expression. So far, we know that 7 is the common factor. What else do we have as common factors?
X and Y.
X.
X squared and Y.
Um, you say x squared and y. Why you say x squared and y?
Oh no. Wait, hold on. No. I got
No, you're right.
Wait.
You're right.
Cause okay. Because 2 because of the 14x squared
Exactly.
and then squared and 49 is cubed. So
Yes.
the common is x squared.
Very good. So she made a very good point. We can't just put x here because it's more than x. We have x cubed, we have x squared, and we have x squared. So each of them have x squared in it. This have x squared in it, this have x squared in it, and this one have x squared in it. And you say, Mr. P, why you say this have x squared in it? Because we can say x cubed is actually equal to x squared times x, right? So we have a x squared right now. Okay. So this term has a x squared, this term has an x squared, and this term has a x squared. All right. So bear it in mind. So let's see who's this. Yeah, that's Joseph. All right. Mr. Joseph Brathwaite, that's you?
Yes, sir.
All right, good. All right, so next up, it's going to be, what else do we put?
So 7 times 7 is 49. So you put 7.
This one.
So
Okay, so 7xy, and it's going to be, what's going to be 7xy? So we definitely going to put 7 because 7 times 7 is 49.
Miss 17.
Uh-huh. Oh, I forget to
Sorry
square
to
it.
interrupt.
Go ahead.
I was sorry to interrupt, right? But health science, what time it ended?
Oh my. Health science all the way down there. Health science is going to end at 8:30, 8:30, like how it always ends every night. Ah, excuse me.
I know I won't make course, so I don't get it wrong. So I don't, because I have something to do.
Okay. Something like play Fortnite.
No, I just want to tell the person the wrong time.
Oh, okay. You mean go on call?
That's what they know.
Yeah, right.
I
Okay.
says I don't do that bullshit.
That's what you say on camera.
I didn't put that, so that's why I got a thing.
All right. This is gonna be X, and this is gonna be Y. Do we agree? Because 7 times 7 is gonna be 49. X squared times X is gonna be X cubed, and Y times Y is gonna be Y squared.
Is it still right? Because I put mine the other way around.
That's still fine. Multiplication is commutative, so whatever way you put it is okay. Even if we did put the 7 last, it still doesn't matter. All right, so it's gonna be plus 7 times 2. It's going to be 14, right? We already have x squared and we already have y, right? So we don't need to put that there. Plus 28. 4 times what number gives us 28? 7 times rather. And what number gives us 28? I can't hear no one.
I thought that you could copy this thing.
Say it again.
Miss Petit, you there?
Hello?
I'm here. Hello. Hello.
Can you hear us or no?
I can hear you.
You the gone.
Oh, you did?
Yeah, I can hear you. What time 7 gives us 28?
Miss Petit,
Yes, ma'am.
for
4. Okay, very good.
would that be
But
for
I thought it's gonna be. Oh, I see.
All right, then it's gonna be y.
Miss Petit, you wouldn't know y squared?
No, we wouldn't put y squared because we already have a y out front. So y times y is y squared.
Okay. For me, for the two part of it, I put 2x.
Okay, the reason why we can't put 2x is because if we do that, if we put an x there, it'll be x squared times x was x cubed, and we don't have an x cubed.
No, you remember I said I put my the part of it the other way around.
Oh, so you put 2. So you did it. You did it like say 7x squared y. So you did 2 plus 7xy plus 4y. That
Oh no. I can type it in the chat.
okay? Yeah, I do that. But that way would also be right.
Miss Petit, do you want to answer what time help?
8:30. 8:30. The same time as be every night. Oh, you mean what time it start or what time it end?
What time it end?
8:30.
Okay.
Good. All right, so we can move off these factorizations, right?
Miss Petit, is this the only question we did tonight?
No, we did
I typed
this.
it in the chat.
Okay, thank you, Miss Kennedy.
Okay.
We did this. We did this. You see this one with the 15x squared y. Let me know if you.
Okay, I see it.
And we did this.
Yeah.
These two. So far,
Okay, so that's all we did for tonight.
yeah, that's all we've been. That's all we've been doing.
Okay.
Now, so we have that. Next up is transformations. I was saving transformation until you reach Miss um, Nancy. So we're gonna tackle these transformations. Take a deep breath in. Take a deep breath
Miss
out.
Petit, I can't do it.
Say it again.
I say I can't do it. I can just watch the recording and what they call. I can watch the recording and then do it one day because the graph wasn't.
Okay, so 7xy. So you said 7x squared y. No, you can't put this 2x. This 2x is wrong. Um, okay, let's see. Let's see how different it is from us. Oh, I see what you did. You also put the 7x squared y. You put that here instead of putting it out front is what you're saying. Hey, Kennedy?
Yes, sir.
No, that's wrong. You have to switch it.
Yes, sir.
You have to switch it.
Wait.
The reason why you have to switch it is because this is the greatest common factor. All right. So it have to be this. We can't have this here because each term have 7, each term have x squared, and each term have y. All right. So this has to be first.
Okay, thank you.
That's not. Any other questions? Okay, so let's do these transformations. So let's try it. Anyone familiar with transformations?
Yes,
Okay, so there are. This is not Shania Fountain. This is not even how she spells her name. I hope, but I don't see no picture. And plus, she isn't. She hasn't messaged me yet to tell me that she is trying to get in. So we'll hope that's not. That's not. That's not. Yeah, that's not how she. That's not. That's not how she spelled her name. So that can't be her. Okay, so we have transformation. One transformation we have is reflection. Okay. No, we can't start off with reflection. That's a bad way to start. We usually try and start off with translation. Right. Now, translation is just what? Anyone know what translations are? Translations. Yeah, I mean, like, what do we mean when we say translation? What is that?
Changing something.
Changing something, I guess. That's a part of it.
Like moving it from somewhere.
Ah, I like that.
rotation, like other side and the push.
So translation is a slide
So is that what you're talking
or
about?
a move, right? Yes. Slide or move. So this,
This could be.
uh,
This could be on my end.
it froze on your end. Oh, it should freeze for real because I'm on the wrong internet.
I can't see what you typing.
Okay, no problem. I know why. I know why, sis. You can fix that right now. Okay. So translation is when we slide or move the image. Okay. So this transformation slides a figure so that each point is moved the same distance in the same direction. So it is a slide.
Yeah, Mr. B.
Hey, can you see it?
You saw a direction. Right?
Yes, I saw a direction. Now it's important to note that with translation, right, no change in size. When we make a translation, we don't change the size, okay? No change in shape. So we don't change the shape of the object. And no change in orientation. It's just a slide, okay? So we don't change it, we don't make it smaller, we don't make it bigger, we don't twist it, we just slide it across, okay? So for example, can I move this?
Not yet, not yet.
Not yet, okay.
Yes, sir.
Okay.
Okay.
Okay. So let's say for example we had a triangle. Oh, let's start simple. Start something with something like this. This is a rectangle, right? Let's say we take this rectangle and we move it, right, such that it turns here. This is a what? This is a translation.
Change in shape.
No, it's a translation. We
It
didn't.
looks different.
It looks different. Oh my, sorry. It's supposed to look the same. So it's the same image. Just we just moved it. All right. So we just move it, or we just slide it across. Okay. So so a next translation that we could have is if we have a triangle and we take this triangle and we slide it this way. Okay, so let me make that better than that. Say we slide the triangle this way, so it's gonna be the same triangle, but we just slide it. So again, no change in shape, no change in size, No change in orientation. We didn't turn it. We didn't flip it. Didn't do none of that. We just slide it over. Okay.
I have a question. Wait,
Go
never
on.
mind.
Okay. So that is translation. So it's a translation. So we just slide it. Okay. Slide it across. Now we could also have something we call reflection. So that's just two other transformations. I'm not gonna go in depth with these like I did with translations because I have to get to the question. But reflection is when you do what?
We like mirror the object.
So mirror,
Mirror
you flip
object.
the object. It's a mirror image is created. Very important. Then we have rotation. What do we mean by rotation?
You like turn
Based on an angle.
You turn around a center,
turn it.
right? You turn around a center. Rotation. And then we have enlargement. And enlargement is when you make something, make a shape bigger or smaller. Okay, that's enlargement. You also might find it under the term dilation. Instead of saying enlargement, people also say dilation. Okay, so you make the shape smaller or bigger. Okay, let me know when you're ready to move from this. So rotation, so translation is simply a slide. Rotation is a turn about the center. A reflection is going to be a flip, flipping the object about a line. Rotation is going to be turned around the center. Dilation is going to be um, making the shape bigger or smaller. Okay. Now,
I'm here.
okay, so so let me just show you examples, just quick examples. So we have reflection. Um, what else? Reflection, rotation, translation, and dilation. Just to show you all the different ones. Um, Again, this is a good example right now. So for our 4-hour translation, notice that we just move the image, same image, we just slide it over. For rotation, we rotate the image about a fixed point, about we turn the image about a point. Dilation, we make it smaller or bigger. Reflection, we reflect it about a certain line. Okay. If that's not clear to you, this is another one that makes it sort of clear. Reflection is a mirror image. Rotation, we rotating it, turning it about a point. Dilation, we making it bigger or smaller. Translation, we just simply moving the image. Simply moving it. I like this one. I like this one. I love this one. This one makes the point clear too. So let's dwell on this one right here. These are the different transformations that we could have. We can have an object and we move it, right? So just sliding it over is going to be a translation. We flip in the object um, along this um, line of reflection, and so this is a reflection like a mirror image. Here this is a rotation. We take in this image and we rotating it about this fixed point, all right, to get this. And then this one is the dilation. Here's the center of enlargement or center of dilation, and we make this image with small, we make it bigger. All right, we expand it, make it bigger. Okay, so that's the thing. All right. Any questions for me? Any questions for me?
No, sir.
Okay.
Mr. the T,
Mm-hmm.
would you consider twins reflections?
If they're identical twins, sometimes they are a reflection of one another.
Okay.
All right, so let's consider these translations and see if we could identify it. This is not as easy and straightforward as it seems, but let's hope and trust that this is stuff easier we could actually get. Sometimes they are tricky and they require a lot of work. Okay, so this is my first time doing this question. So let's see how good we do it. All right. When I say first time doing this question, I mean this particular one. Um, we did a transformation question in class today, but I didn't do this question. So it's my first time tackling it. So let's be tackling it together with the same eyes. So let's see if we can get it. So we want to describe completely the single transformation that maps figure A, that maps figure A onto figure B. So this is figure A right now in all its glory. This is figure A. And we're trying to figure out if we take figure A and we map it, if we take figure A and the image is B, what would be the transformation? Looks to me like a reflection of some sort. What do you think?
Yeah, it will be a reflection.
It is a reflection. I think it's a reflection as well. But a reflection about which line? So I think it's a reflection along the line y equals to 1. Let's see. I think this line right now
Yeah.
is this. I think this line right now is the center of reflection. Okay. So let's see. I think so, because if we move this 1 unit and 1 unit, that's 2, right? So it takes 2 units to get to the line of reflection. Now, if we were to do it again, this is going to be 1, 2 units. All right. So they are equal distance apart. Let's look at this guy. This is going to be 1, 2, 3, 4 units away. So the next corresponding point should be 4 units away. So it's going to be 1, 2, 3, and 4, right?
Yes, sir.
And then we have um, this guy. This is 1, 2, 3. So we expect that the corresponding point should be how much units away? 1,
You say it's 8?
2, 3. So I believe that this is a reflection. It is a reflection. The line of reflection is y equals to 0. The line y equals to 0. So the answer for this one is, this is a reflection. This is a reflection in the line y equals to 0. So we got that. Let me know if we get it.
So, but I have a question.
Go ahead.
If you do like a tracing paper, you do it right. But you gotta, I got the same. I saw it, but how like did you know that refraction line is y equals 0? I wasn't
Oh, how do I know that the line is y equals 0?
the for refraction because I didn't know that.
Well, because this is the line y equals to 0. If we do this line right there, right? Let's say we do this line right there, the line that passes through 4. What do we call that line? What do we call that line?
Can you repeat that?
The same red line right there. This one. What do we call this line?
You mean the y-axis?
The same line right there. This line right there. What do we call that line? It's very one. This is the line y equals to 4. We did this before. This is the line y equals to 4. This one is the line what? The same line as what?
Y equals to 5?
Yeah, y equals to 5.
Oh, that's how you get y equals to 0.
Yeah. So therefore, you know that this will be y equals to 0.
Oh, that's how you found it, man. I
Oh.
thought it was y equals to 1 because
It can't be
I
1
thought it's
because
y.
this is 0 and then this is 1 and this is 2.
Oh, I was counting it this like long across.
Oh. But now you know.
Mm-hmm.
So Miss what's in Miss Joseph, does that answer your question at all?
So I just wanted to know. I don't know.
Pardon?
I said it did. Thank you.
Okay, okay. You have the Coley.
No, I guess I do.
You just what?
A little off.
A little off. You have COVID.
No, I don't. I guess a lot.
I'm surprised you won't see that's a non sequitur. I'm gonna fallacy from yesterday.
Yes, I was gonna say because I get the vaccine.
That's a good one. Yeah, yeah, that's a good one. Okay. Okay, so this is a reflection in the line y equals to 0. That was an easy one. Hopefully all them easy like this.
I doubt it.
Please, don't say that. Don't say that. You're hoping for the best. So let's go. So we have to describe completely the transformation of maps. Figure, next one is going to be figure A to C.
I was saying,
Say it again.
I was saying figure A and with A, B, C. I mean A, B, C, and E. And I like.
Okay, so we have to be careful because they say we want the transformation of maps figure A to C. So we have to ask ourselves, first of all, what would it be? Would it be a reflection? Is it a reflection from A to C?
No, sir.
No, that can't be reflection. Reflection usually stays in the same, orientation. No, it's not. It really doesn't change. They should be like equal.
Actually,
Like they should be.
rotation.
Um. Mm, it looks to me. Did we change? We change. We turn it. You notice we turn this, right? We did turn this.
Rotation.
Say it again.
I said it looks like rotation.
It looks like rotation
I
is
think it's
correct.
rotation.
I think it's rotation as well. It's a rotation of how much degrees though? Looks to me like
Um, okay, 90, 180.
it looks to me like a 90-degree rotation. If you ask me, it looks like
But don't you go anti-clockwise or you can go both
it doesn't
ways?
matter because
You go
if we go this way, that would be what clockwise, right?
90. Yeah.
So I think it's a 90-degree rotation clockwise. My guess is this is my guess. It looks to me like a sorry, I spelled guess wrong. It looks to me like a 90-degree rotation clockwise. But the question is, and I hate this. The question is, what is the um? So my guess is a 90-degree rotation clockwise, right? And I'm gonna say about the origin. That's the center of rotation about the origin, right? That's my guess. But we have to verify it. Okay. So this is our guess. We saying it looks like a 90-degree rotation about the origin. I just concerned that that's my thing. I don't think it's about the origin because it doesn't stay in the same thing. Like it's like. But anyway, let's just say it's about the origin, and then let's check and see if it's about the origin. So the first thing we're gonna do is we're gonna label our points. So we're gonna label this. We're gonna label this A. Gonna label this point A. Right. We're gonna label this point B, and we're gonna label this point C. All right. So let's do this. So if we do that, this is gonna be we know that we're gonna have a pre-image. Um, sorry, we have the image, and we have the actual. All right. So the pre-image is going to be what's the coordinate of A? The coordinates of A is going to be what?
No, yes,
Say it again.
like negative.
The coordinate of A. What is the coordinate of A? Is it not
One, one,
One and negative.
one,
one and
one, negative,
one and
Negative
negative
two.
two?
negative 2.
Yeah, one and negative two. So it's gonna be one and negative two. What's the coordinate of B?
3, -3.
The coordinate of B is going to be 3 and -3.
-3.
Very good. 3 and -3.
I can see the image again.
Now we need to figure out what is the point C. C is going to be what? 2 and -4.
1 -4.
2 and -4. Right? 2 and -4. All right, good. Next, now if it's very important, if this is a 90-degree rotation clockwise, there is a rule that we have to use. Let me tell you the rule. It's a 90-degree rotation clockwise. Remember, that's our gas. The rule tells us, so it's rotation, 90-degree rotation clockwise rule. The rule tells us that if it is, so let's go. So if it is
We writing that?
just the 90-degree one, but I would write the whole thing if I was you, but take a screenshot. You can't write all now. Um, but all of them are important. You're supposed to know them what you had. So what the rule says is that if your point is xy, and if it's indeed a 90-degree rotation clockwise, then your your image, right, after rotation should be, what you're gonna do, you're gonna take your y, you're gonna put it for the x, and you're gonna take the x and you're gonna put it for the y, and then you're gonna negate the x value. Right? Let me say that again. If it's indeed a 90-degree rotation, you're gonna take your x value, put it for the y, take your y value, put it for the x, then you're gonna take your x value and negate it. So switch it and negate the x value. All right. So let's do that. So what is the first thing we're gonna do? We're gonna switch it, right? So our a prime supposed to be, we switch it, so it's gonna be -2 and 1, but then we must what? Negate the x. Same thing for b. It's gonna be b prime. We're gonna switch it, so it's gonna be -3 and 3. The next thing we're gonna do, we're gonna negate the 3. So c prime again is going to be what? We switch it, -4, then we negate the 2. Okay, so that's if this is 90-degree rotation clockwise, this is supposed to be our coordinates. If that's the case. All right. If that's the case, go back to the roots. Okay. All right. Can I move now?
Hold on, let me take the screenshot.
Yeah, take a screenshot. So if this is indeed a 90-degree rotation clockwise, then it should follow the rule for our 90-degree rotation clockwise. It should follow the rule. All right. So we're gonna check the image and see if it follows the rule. Okay. So again, if this is a 90-degree rotation clockwise, it will follow the rule. So let's actually see what's our actual values. So a, we're gonna say a bar. Okay, a bar is going to be equal to let's see. What is this? Sorry, let's go. Where's that point? Sorry, I lost it. Okay. This point here. This is A, right? This is A double. This is A bar. Why is this A bar? Because it corresponds with the same point right now. So I call it A bar. That's what I call it. Okay. To distinguish it from A. Okay. So what is the point A bar? That's
-2,
-2 and -1.
1.
-2 and -1. So -2,
Yes, sir.
-2 and -1. Does that correspond with? Does that correspond with what the image is supposed to be? If it's a 90-degree,
Yes.
it does, right? Okay. So it looked like we're on the right track. Looked like our guess was right, but we are not sure if our guess right until we check all, right? So let's go to B bar. Let's keep our fingers crossed, and we're gonna go to B bar. So B bar, this is the actual thing. Let's see if it works. So B bar should supposed to be here, right? This is B bar. What's the coordinates for B bar?
I know, correct. We have -3. We have -4. Right?
So -4,
-4 and -2.
-4 and -2. Okay, so -4 and
That's
-2.
B?
Yeah, that's B. So maybe it's supposed to be for CA. Let's see if we rotate this 90 degrees. Oh, that's true. If we rotate it 90
You go
degrees,
wrong.
this is supposed to be C bar. My bad. This is
Yes, sir.
supposed to be C bar. If we rotate it, it's supposed to be C bar, and this one's supposed to be B bar right now. You understand? Like if I rotate this point would become this point, and this point would become this point. All right. So let's do B bar. B bar is gonna be what?
-3 and -3.
-3 and -3. Good. So -3 and -3, and then C bar is going to be what? -4 and negative.
-4 and -2.
Very good. So -4 and -2. So what does that tell us?
Answer right?
Yeah, our
Yes, I can.
I guess was right. So our image, the image when we rotate it 90-degree clockwise, corresponds to what we actually have, right? And so what that means is that we can say, let me know when I can move this, please.
Okay.
That means that we can say that the answer for B is going to be this is a 90-degree rotation clockwise clockwise about the origin. And the origin is the point 0, 0. So that's the correct answer for us right there. So it's a 90-degree clockwise, 90-degree rotation clockwise about the origin.
Mr. Petite, not like to the good, right? But if you were to do it counterclockwise, would you still be able to get the same answer?
Yeah, definitely. So what we do is we would use we would use because if we do counterclockwise, I think it's gonna be 270 because it looks like we shift it one, two, and three if we do it counterclockwise. So my guess, if I was doing it counterclockwise, would be that um, it's a 270-degree rotation clock counterclockwise. And so what I would have done is I would have used the rule, but look at this, it's the same thing, eh?
Yes, sir.
Yeah, it's the same thing. So essentially, both of them is the same thing. So we could say rotation of 270-degree clockwise about the origin, or we can say it's a 90-degree rotation clockwise about the origin. Both of them is the same thing. Okay. All right. So let's go back to this. So you must state that it's a 90-degree rotation clockwise, and you must state that it's about the origin.
Why did you put in brackets 0-0?
That's what the origin is.
Oh,
Mm-hmm.
okay. And origin represents
Say it again.
what if like so if I don't put origin, what am I saying?
Say it again.
If I can you hear me?
I can hear you.
Okay, if I don't put origin like at the end of the answer, would it change like I must be penalized?
Yeah, because it's 3 points. So you need to say it's a 90-degree rotation. You need to say the degree, you need to state the direction, and you need to state the point of rotation. Right? So you need to state the degree, state the direction, and state the point. So we say it's 90 degrees, we say it's a rotation clockwise, and we say it's about the origin. All right, each of those things are important to get you 3 points. And the origin, of course, is the middle value right there. This is the origin, the middle, the 0.00. Okay, can I move?
Yes,
All right. Okay. Okay. Next up, so we go back here. Number figure A to D. I wonder if you have enough time for this. We have to go on to health science, but let's see if we have enough time. So far we did a rotation. We did a rotation. Um, we did a reflection. We did a rotate. We did a reflection. We did a rotation. Now we are about to do a. We don't know what we're about to do because we don't know what it is. Either it's gonna be a translation or it's gonna be a dilation.
It's a dilation.
You think it's a dilation? All right. Says the mathematician in the corner there. I trust you, Miss Rackley. Up and coming mathematician. Don't worry. By the time you finish with these classes, you'll be changing your major from doctor in medicine to doctor in math. Right, Miss Rackley?
Yes.
Right, Miss Rackley?
I can hear.
You can't hear me?
can hear you now.
Okay. I was saying by the time you finish these classes, you'll be doing a doctorate in mathematics instead of medicine.
No,
Say no.
I don't like to be honest, but I just doing it.
You're just doing it. You're just doing it to get to that to get to medicine,
Yes,
on
sir.
the road to medicine, eh? All right. All right. So it's a dilation. It is a dilation or an enlargement. That one is easy. But we need to determine for enlargement. We need to know the scale factor. We need to know the scale factor. Sorry, let me write that properly. For enlargement, we need to know the scale factor. Okay, that's important. For enlargement, we need to know the scale factor. We also need to know the center of enlargement. We need to know that. So we need to know the scale factor, and we need to know the center of enlargement. Um, what else we need to know? A scale factor, the center of enlargement, and that is enlargement. That's it. So the way how you know the center, let's find the center of enlargement first. I believe that the center of enlargement here is the origin. That's my belief, but that's my guess. But we have to verify. So the way we're gonna do that is we're gonna use three important points here. So we're gonna use this point. This point should correspond with this point. All right. I think it's the origin, but we'll see. Then this point must correspond with this point, and this point, and so on. So we have to draw, in order to find the center of enlargement, we have to draw a line through all of them, through the corresponding points. So we have to take this line right here and draw it to connect. So this point and these two points we must connect. All right, they must connect. So can I enlarge this thing? Okay, good. So let's do this. Let me move this on the side so you can see properly. Does that even work? No, that don't make a difference. Okay. Hopefully that's better. What I mean is this point and this point we must connect them with a line. So let's do that. So we're connecting them with a line. Okay. I assume it's the origin. So let's just say it's the origin. Let's just see if it works. So that's in hiding this put some more weight on this line right now. Good, that's enough weight. Next we need to take another line and connect it to we need to connect it we need to connect this line with I'm gonna change the color of this line. Say let's change it to yellow. Good. And so this yellow line must pass through. So this line and this point was connected to this point. Is that true? I feel like I off somewhere. So this point is supposed to be connected to that point. It's not true. Okay, let me not do that one. Let's do this one first. I know for sure this point must connect with this point. Sorry. I know for sure this point must connect with this point for sure. Okay. Okay, we know that for sure. Um, it's 3 points. So where does this point go? Where does this point go? Okay, so these two for sure, and then this point right there. Oh, I see the problem. This point and so this right there. So right now, these two, these two, um, I think they're supposed to be good. This is going to be right here. All right. Next up, this is going to be um, this comes through here. One moment.
Mr. Petit,
Yes, mom. Okay, I was trying to find out which
you
way.
can let me on my phone,
Say it again.
please.
Why? What happened?
You can let me on my next device.
Okay, I could just sign in.
Then
Okay. So, what I was trying to say, sorry, is that this point and this point, these 2 points must connect because this point is the enlargement of the same point is the enlargement of this one. It's like how this point is the enlargement of that one. This point is the enlargement of that. So these two must connect. And I'm just gonna send it back here. Okay. And then finally, there's a third one that needs to be drawn, and it's right here. This one and this one. You have to be very careful because it's the same thing. So there we go. So all them are passing through the origin. So the origin is the center of enlargement.
If you don't leave me alone, I curse your life in the mouth. Jesus of Nazareth.
One moment.
Trust me. Your life cursing Jesus. You should try someplace. I think it's just like some kind of. What do you think I is? In the mouth of Jesus of Nazareth, your life curse. Question anybody in your name, Ashia? I thought that was half. Your life curse. You shall try someplace. Yeah, you never question me, Papa. May the Holy Ghost stop like that.
Okay, sorry about that. What I'm saying is, if we look carefully, right? That's the thing with these questions. You have to look. Look at the brown line. Look at the yellow line, and look at the blue line. All of. Hello, can you hear me?
I just saying a graph.
Yeah, it is. It is. It is. It's kind of difficult, but we have to we have to look carefully. If you look at the blue line, if you look at the brown line, and if you look at the yellow line, all of them intersect at the origin. Okay, all of them intersect at the origin, and so the origin definitely is our center of reflection. This connects with this. We can clearly see that. Okay, that point and that point, and surely this point and that point. Yes, that's true. That's true. Good. Okay.
I have a question.
Go ahead. Go ahead.
Okay, if it didn't line up, or right?
Say it
The
again.
line up it, we had a number. I said if it didn't line up the origin, like if it we had a number, with how would that?
Say it again. Oh, if it didn't line up with the origin, then whatever point that is that where they connect, it would be a center of enlargement. You
And
understand?
then instead of or
Instead of the
the
origin. Yeah.
the number.
Say it again.
Then I said instead of the origin, you write the numbers.
Yeah, you write that point. Yeah.
Okay, okay.
But usually it is the origin. From my experience, it usually it's the origin. All right, so now let's do it point by point. So I'm gonna move these lines for a moment so we can focus on what we need to focus on, just one. So let's focus on this particular brown line, okay? So if you look carefully, I'm going to separate my thing into two. So I'm gonna divide it into pre-image and image. All right, and we have to be following very carefully, okay? So we starting from the origin and we trying to get to this point. I'm gonna use this, I'm gonna color this point as green. So we starting from the origin and we trying to get to that green point, okay? So we starting from the point 0, 0, that's the origin, and we trying to get to the point that is in green, that's the point 1, negative 2. And so what is our rise and what is our run? What is our rise and what is our run? So our rise is going to be 1, 2. So rise is going to be 2. And our run is going to be 1. Come over. Okay, so it's 1. So the next thing is going to be, we're going to start from the origin again. But this time, instead of considering this brown line, we're going to be considering this yellow one. And the other one is from here to here. And so we're asking ourselves, how do we move from 0 to this point right there? 0 to this point. So remember we started the origin, sorry. We started the origin, so this is going to be 0, 0. You're trying to reach to that point, this very point right there. To get there, that's the point what? 3, 3, 3?
Yes, sir.
Okay, so rise over run is going to be 3 over 3. And then the last point is, we start at the red again, but this time we're trying to get to this one right there. Okay, so we'd go 1, 2, 3, 4, 5, 6, 7, 8. So the run is going to be 8. So, sorry, rise rather. Rise is going to be 8. And the run is going to be, how much is the run going to be? 1, 2, 3, and 4. It's going to be 4.
4.
No, 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 my bad, my apologies. We have to consider not that one yet. Not this one yet. We haven't reached there yet. We still on the little ones, the little 3 dots. So the little 3 dots is going to be this one. So we're still on this one. So that's going to be, my apologies, 1, 2, 3, 4. So that's, the rise is going to be 4. And the run is going to be 1, 2. And what's that point? That point is 2 and -4. Okay, good. So that's the pre-image. Now let's look at the image. So if we look at this point, the point that is the pre-image to it, sorry, the point that is the image to it is this point, right? So we're gonna consider rise over run for that one. So rise over run for that one is going to be, this is the point what? 6 and -6. Oh no. For this one, it's for this point. Okay, for this point, for this very one, it's gonna be 6 and -6, isn't it? Because here we have 6 and here we have -6, and so this is gonna be rise over run is gonna be 6 and 6. For the first one, we are considering this point as it relates to this one, and so that one is 2 and 4. So 2 and 4. So that one is 4 over 2. 2 right there and 4. So that's 2 -4, right? So that means we had a rise of 1, 2, 3, 4. Yes, someone saying so?
Never mind.
And we have a run of 1, 2. So that's going to be 2. All right. Next, we have the third and last one, which is rise over run. For this one, we have this point. We're trying to connect it to this point. So what is this point right there? This is the point. What was our rise? 1, 2, 3, 4, 5, 6, 7, 8. So our rise was 8. Our run was what? 4. Yes. 1, 2, 3, and 4. Good. All right. So we have all them. Now we're trying to figure what is the scale factor. So the question is, how do we move from 2 to 4? How do you move from 2 to 4?
You go over to your left.
You multiply by 2. How do you move from 1 to 2?
You multiply by 2.
Very good. How do you move from 3 to 6?
Multiply by 2.
How do you move from 3 to 6?
2.
How do you move from 4 to 8?
2.
How do you move from 2 to 4? 2.
Multiply by 2.
Good. So the scale factor is 2. All right. Do we understand how we got that?
Yes, sir.
All right. Nancy, you got it?
Practice in this direction.
Yeah, I feel like
I got to thinking, but until I did, I'm sure I did, right? I looked at it, I looked at the other one, and I just see that it was like double the amount.
it was like double the amount, exactly.
So this is currently something happened. How do you do all this? It's practice.
Yeah, definitely some practice on this. Um, Kennedy, you understand what happened?
Yes, sir.
You sure? Sure?
Well, no.
No. Okay, but you do understand that it is scale factor of 2.
Yeah, I understand the basics of it.
You understand the basics. Okay, that's important. I know you don't understand the rise of a run, everything, and all the dots connecting, but at least you understand that
Yeah.
it enlarged by 2. Okay, and in the exam, they don't really need all this working. Okay, I just did it, but they don't need all that working. Once you know how much it's scale factored by, for me, I did this working so I could be sure what it was a scale factor of. Okay, that's why I did all that working. I wanted to know how much it increased by. Um, but to be honest, you only need to do it for one, because if you do it for one, it should work for all. Like like if we was doing it for just this one, and we already see that once we multiply, um, you already see that once we multiply this coordinate by 2, we get 6/6. Um, we already know that 2 is a scale factor, so we didn't have to do it for all three. Um, so therefore, for the answer for this one, you'd say this is an enlargement. This is an enlargement. I feel like I spelled enlargement wrong. Am I spelling enlargement right? Okay, yes, it is right. This is an enlargement with scale factor, or with a scale factor of 2, right? And with the center of enlargement being the origin. Okay.
Yes, but I honestly don't see why I got what I got on my paper last year. 'Cause I didn't know these things.
Yeah. Yeah. Now you know. You still need a lot of practice. Um, but at least you have some understanding of the basics. Okay, so say it again.
When we start in health.
When you stop asking.
What'd you say?
When you stop asking.
I just want to make sure because I need to know what I need to get help.
I don't know. I don't know what why you so anxious to go somewhere. You wanna have school?
No, I won't go nowhere. I just need it because it past 8 o'clock.
Okay. You're a student. You don't have nothing. You don't have no important place to go.
But the thing, I didn't say I got something to go. I just asked him what time we doing it because sometimes you forget. You don't see the time. That's why I just reminding you that we got help.
No, I always see the time. I know the time. I forget.
Never mind. Never mind.
This girl is so bad. All right. Any questions on this before we leave?
Just send me some answer questions.
Send you some extra questions on this. Hello? Hello, can you hear me? All right. Can you all hear me?
Yes, sir.
Okay. Um. Okay. Are we done with this?
Yes, sir.
Okay.
So, can you just send me some extra questions?
Okay. So before we go, I want you all to try this one for homework. We still have to do figure D, but try this one for homework. Nancy asking for the extra questions on transformation. So um, let's do it. I want you all to try this one for tomorrow.
Not now, I'm late for the other class.
Try it, and then we can discuss it on tomorrow. Take a screenshot of it.
I took the screenshot.
Good.
Oh, and then laptop, you could press like the little square button, and then you could press the button after F12, and it could do the screenshot for you.
Yeah. So just press that. Or go look at the recording. That's fine.
See, after what? After F12?
Okay, you see where at the bottom of your keyboard, you can see FN, right? It's a little button down to 4 boxes within the window. Okay, the window button.
Window button.
Yeah, and then you're gonna go click the button after to F12.
The window button, PRT.
Yeah.
Yeah, yeah.
For the,
I see it.
for the press them together now.
They
For the press
Press
it.
the Windows 1, and while you holding it, press PRT or PRT.
Yeah.
I think you get it.
Sure. You have to press it twice. You have to press it together. So make sure you hold on to one.
Press the Windows 1, hold on it, and then press PST or PRT.
You can know like when it's screenshot, that's your screen go blank.
Yeah, your screen go blank.
Thank you, you get it.
Good stuff. All right. So. All right.
Alright, I'm out.
All right. So good night for those who are um leaving. Good night. But we gotta do health science and general science. We gotta squeeze that in because math been taking up a whole lot these days.
Time class over, Mr. McGee.
9. Same 9. Um okay, so let's continue.
You said 9, right?
Yeah. Yeah, 9.
If we get on that Christmas week, we get a little break day. Lucky. Anna Blanc? That's a plan?
No, that no plan.
So
Yep.
we got to get our Christmas break, our Christmas present from you.
The Christmas present. The Christmas present is one more hour extra.
What?
That's the Christmas present. Free of charge. Your parents don't have to pay for it.
See, that's worse than cold rocks.
January will be that smooth sailing, Mr. Petit.
Boy, January, I feel sorry for y'all. I'm gonna be coming over there at 10 o'clock. I'm gonna be coming over there at 10 o'clock and stuff.
What?
Mm-hmm.
Funny.
Especially coming up the day before the exam, it'll be an all nighter.
Oh, no, yeah, you can bear with that. I can bear with that. Wow.
Day before the exam, that's an all nighter, boy.
I
Yeah,
can
we can
do
do
that,
that.
but
We can
not
do that.
the one night Tim.
That's the same thing before. That's the same thing before. That's the same thing in January. Think about January as once you see January it over, y'all exams right there.
True.
Okay. So last thing we did in health science was the 7 characteristics of living things. So let's continue with that. So we on growth, right? Or we finished growth? Let me know. What's the last thing we talked about?
Sensitivity.
Responding to sense stimuli. Okay. All right. So we on living things grow. So living things. Living things grow. All right. So we have to explain that a bit. It's pretty straightforward. Um, when we say living things grow, growth just means a permanent increase in the size or the mass of a particular entity. So, for example, so let's explain this. So, as an animal, excuse me, as an animal or plant develops, it gets larger and what? And heavier, right? So, even when you look at yourself, would you say that you've grown? That's a question. Would you say that you have experienced growth? Any of you? Are you here? Can you all hear me?
Yeah, yeah.
Okay. I'm saying, if you look at yourself, would you say that you've grown? Would you say that you have experienced growth? Yes. Okay. Good. You know that, and you know that is because your arms get longer, you get taller, you start to become taller than your mommy and daddy. You start to become taller than the people around you.
They can't grow. I ain't know why. I grow the I know.
You shorty like me.
Yes, kid.
That's fine. It's the short people. Short people.
No shit. Short niggas run into y'all.
Yeah,
Nah,
exactly. Exactly. So, in other words, it grows. So, in this process, please take down the following notes. In this process, its volume and mass going to increase.
this head rate, Mr. D.
Yeah, the cell time.
They catch me little, me little, little finish that, yeah.
All right. Now, growth, growth takes place by substances being taken into the organism from outside. What does that mean? How do we grow? What do we need to grow? It says substances must be taken into the. Say it again. We need what? Say it again. Or testosterone? You mean the hormone? Um, that's true. But even more fundamental than that, if you don't blank, then you can't grow. Come on, baby.
Miss Fitzy, what you say? If you don't wait, you don't grow.
If you don't blank, then you can't grow. What is that?
Eat.
Well, yeah, like that is the song say,
Right.
read your Bible and pray every day. That's true. But if you don't eat, then you can't grow, right? So you need to take in substances. So you need food, right? So you need fats, you need carbohydrates.
Protein.
Yes, you need protein. You need vitamins. You need minerals, right? Where do we get fat from?
Butter.
Okay, oils, coconut oil, olive oil. Um, we get it from nuts as well. We get it from
Avocados.
avocado. Yeah. Fat also fat also come from fatty foods like grease. You know, um, cows, pigs. Yeah. Carbohydrates. We get carbohydrates from stuff like bread, stuff like cassava, plantain, um, potato, um, rice. I said rice, grits. Um,
I can't see you typing nothing.
I am not typing anything. I just list fats, carbohydrates, and proteins and vitamins and minerals. I haven't typed anything significant yet. Let me see something. Maybe. All right. Let me share my screen again. Stop presenting. I'll share my screen again. Okay. Can you see what I have here? Can you see what I have here? Yes or no?
No, sir.
No.
I can't see.
You can't see anyone else?
Mr. Petit,
Yes, mom.
I can't see a
Can't see my screen. Okay. Okay. So okay. Open your eyes. Then you can see it. I wanna.
I can
Oh.
see the glasses, but I ain't see nothing.
internet meter.
You can't see nothing. Open your eyes again. Why you open your eyes? Okay. All right. Let me just read it to you what I have on the screen, and then um while it's trying to come up. So I have as animal. You wanna have nothing at all. Hey, Miss Cooper. You don't have nothing at all.
Can you repeat that?
Do you have anything at all? Did you see anything at all that I started writing?
I have. We mean if I have the notes what you was right doing?
Yeah.
You're saying up to minerals.
Or up the minerals. Okay. Okay. Where do we get
Yes.
where do we get
Can you repeat that?
I was saying, where do we get protein from?
Milkshake.
Say it again. Where do you get protein
Egg.
from? Eggs, yes.
Huh?
Protein. Anything of the in the animal world. So like beef, chicken, um, beef has protein, chicken has protein. Um, what else are protein? You get protein from nuts. You get protein from beans. So like black bean, pinto beans, all type of beans. You get protein from almonds. Um, let's look it up. Animal sources of protein. See what they tell us. Wheat, might meat, fish, pork, ground beef, all those stuff. Now, plant sources of protein are going to be tofu, peanut butter, um, and the like. Okay, vitamins and minerals. So when we take these stuff in, the protein, the fats, the vitamins and minerals, our body is gonna use it. Right, our body is gonna use it to grow. Okay, so that's why it's important to eat. Okay, because if you don't eat, then you can't grow. That's just what it is. All right, Michaela, is that you? Michaela, is that you? Okay. So next up, we have. She said yes. I think I already removed her. All right. Okay. Good. Okay. So next we have. So that's why it's important to eat so that we could be able to take these stuff in. Next up, these substances. Speaking about the things that we take in, these substances are then built up into structures of the body, and they become a part. They become a part of the organism. That's why people say you are what you eat. Whatever you eat, that's what your body take in to use as energy. Okay, so that's why it's important. It's important what you put inside your body because you are what you eat. So if you eat garbage, you are garbage. Not really that you are garbage. Your body would feel like garbage. You would feel like you ever eat something and then something you know you shouldn't eat and then you end up feeling bad. That ever happened to anyone? Yeah. Okay. What was that you ate? What was that? Uh huh. Yeah. Yes. Yes. All right. So a plant, such as a tree, keeps on growing for the rest of its lifetime. So goes. Y'all see my screen? It goes on growing throughout its life. Animals usually stop growing and they reach a certain age. When do humans stop growing?
At the age of 25, I'm 21.
21. This book tells us that humans usually stop growing at about 18. And that's as a general rule. Some people still grow after that, but generally speaking.
Teacher, fuck me in my fucking ass. That fat, juicy cock.
I had a feeling.
Wait, Jai slide with you, yo.
That was a beginner.
I had a feeling. I had a feeling. I don't know how we get a picture.
Nasty.
That's why they use Michaela name, see. And that's a real name.
But it has a double. It has a double. It has a double Y.
I want to see somebody using my name. Oh, John.
Wow. It has a double Y.
And Michaela Shane in the show.
Michaela, she was in class today.
Right. From the start, I knew it from the start. She usually have a microphone on. I knew it from the start.
Yeah. But they used a picture. I don't know how they get a picture. That's strange.
Somebody did.
I believe when they come in this class, there's like seawater. It's right down the class.
But how they get her picture? That's my question.
Helping them.
But how?
They screenshot it and clip it. That's all. They only use the screenshot and put it as that.
That's true. That's true. That's true. For example, humans usually stop growing at about 18. But they so I think is that they so you could use any other joke, but why they always so promiscuous?
Sexual.
Yeah, that's I don't know, man.
They are mature.
Yeah. Yeah.
I bet they 12.
No man, I ain't sound like no 12-year-old. I sound like a grown man who ain't got nothing to do. Exactly.
That's sad. Yeah, that's a sorry excuse to be a whole human being.
Exactly.
Making weird sound.
Exactly.
Like some animal. We better get excited about it as well.
You already out Kennedy.
Who's the pastor, man? That poison come here, we let the pastor preach.
For example, humans usually stop growing at about 18. 18. Anyone here about that age? No one here 18?
Yo, they say the 19 to 21.
What? It was 25.
Yeah. This book saying 18. Okay, so even when growth stops, um, materials of the body are constantly replaced by new substances coming in from outside. So even though you might be 25 and you stop growing, right? you still could grow muscle, right? So if you go to the gym and if you say it again.
Um, 20, the age at 25 is your prime years, and that's when everything starts to develop good at that time.
Yes, that's also true as well. But even if you in your 40s and you go to the gym and you
I ain't gonna do that.
yes, you still could grow muscle. Still could grow
I
muscle.
don't know who that.
Yes, you still could grow muscle. I'm telling you, you still could grow muscle.
We all could do it.
Yes, you still could grow muscle. Right? You still could increase muscle size once you eat. Once you eat and once you exercise, you could grow muscle. All right. So even when growth stops, materials of the body are constantly being replaced by new substance coming in from the outside. So this process, so every day cells die in your body and they are being replaced. All right. Just like your skin cells, right? These are not the skin cells you were born with, right? Every so often these are going to be replaced, all right, for new ones. Because think about it. Anyone ever cut like a large scar? I have a large scar on my elbow, right? Um,
Yeah.
or underneath my arm, really. Um, and the skin cells would die, and then new ones would come there, right? Okay, and so it's being replaced, and so more and more as I grow older, the scar would not be there anymore. Anyone like that? Like as you grow older, the scar you don't see the scar no more, or you see it fading
Yeah.
away. Yeah, that's the same thing. The process is being renewed. It's like the scar was much more um on my hand. It was much more deeper. I'm even surprised to see how much it cleared up, right? So that's because it's renewed. So this process of renewal goes on.
Quick question.
Yes, sir.
Like when you get checked or you get paid or start, you
Yeah.
don't
Say it again. Say it again.
you see when you get stabbed,
Mm-hmm. Go ahead. I can't hear you.
it would be
Yes, sir. I can hear you now.
like I said I get peg on my shoulder before in school. I
Mm-hmm.
saying the sky ain't moving, but it's just like there. So it's just there healing everything. But it ain't moving.
Um, as you grow older, it should get smaller, or it should get less. It should be fadey. It should get more fadey, right? Depends on how deep it was, though. So they're saying that every 4 years, there's a total um renewal of your body. So 7 years, every 7 years, your body totally renew itself every 7 years. Okay, and so that's why. So by the time if you're 16 now, your next renewal of yourself is going to be when you're what? If you're 16 now, when it's going to be your next renewal.
Anyway,
When you reach what? How old? I can't hear you.
so they going
Yeah,
up.
yeah, I get you now. When you reach how old?
I see 30 or 22,
No, 23, because it takes
23.
yeah, it takes 7 years. So if you're 16 now, in 7 years, you would have a complete turnover. Okay, so when you're 23, it's a renewal. Okay. All right. So are we good with this? All right. Are we good with those notes?
You went back out of generalized for a second.
Okay. Okay. Where did we left off for general science?
Sensitivity.
Say it again. Hello.
Everyday positivity.
Say it again.
I got
Okay. I'm saying where did we left off for health science? I mean for general.
Sensitivity.
For general? General
That's
science?
all.
General science? General science. So this was general science that we was talking about? I thought this was health. Doesn't matter anyway. So we was on cells, eh? When
So
did we do cells? I remember we was doing cells for one of them.
there is starts off with the microscope.
Yeah, the cells is what? The cells was for health or general?
Health.
Oh, okay. So Conrad, this was general just now.
What you say this was?
This was general.
They have
it's general.
Yeah, this is general.
We didn't really
Let me screenshot that and slide over there.
Yeah, this is,
because there was health science. We supposed to learn the systems.
yeah,
So we ain't doing health aid.
yeah. Health right now. We're doing health right now.
Hey, I accept the Early Christmas present.
All right.
Sure.
All right. Okay, so we was talking about the light, the difference between the light microscope and the electron microscope, right?
so
Yes or no?
yeah.
Good. Okay, so that's where we ended, right?
Yep.
Okay, so let's finish it off. Sorry about that, Miss Cooper. We doing health right now. Okay, so um,
Russian real body get out of here.
I notice. I notice. Well, we have a date, a virtual date. Okay, so all cells have a membrane, a cell membrane. So
Yes,
whatever
sir.
whatever sort of animal. So this is health science now. Sorry about that. We almost end. We end at
All right.
9. This is health. No. So whatever sort of animal or plant, sorry, or yeah, whatever sort of animal or plant they come from.
Can't see your screen.
You can't see my screen? Okay, thank you.
Close up.
Okay, good. Can you see it now?
Give me a statement, Mr. Cookie. There you going?
Okay, you already got the screenshot?
Screenshot it, there you go.
Yeah.
Okay. Get it.
Okay. The wrongest thing y'all do is teach Conrad how to screenshot. Whatever sort of animal or plant they come from, all cells have a cell membrane around the outside.
It's still general.
Notice it's health now, my dear. Now inside the cell membrane is a jelly-like substance called what? What do we call that jelly-like substance? Called what?
Chloroplast.
No, 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 no.
Cytoplasm.
Cytoplasm. Very good. Cytoplasm, in which are found inside the cytoplasm.
Yes.
Yes, yes. Many small structures. What do we call the small structures inside a cell? You all should know this. Organelles.
Organelles.
Yeah, organelles. All right. The most obvious. Can you all see my screen?
Yes, sir, we can see your screen.
Okay. The most obvious of these organelles is the nucleus. The whole content of the cell is called protoplasm. So if we do this, if I were to draw a diagram of a cell, it's a simple cell, like so. This is a plant or animal cell?
Animal.
Animal, very good. How do you know it's an animal cell?
Because it's round. That has the nucleus inside.
Okay, because it's irregular in shape, right? And so we'll have these things around it, different organelles around it, inside the cell, doing their thing. All right. So where is the cell membrane, or what is the cell membrane?
Proteins will enter and leave the cell.
Very good. So that's the cell membrane. right there. So
Can you repeat that?
yes, that's the cell membrane. Okay, it's found on the outside of the cell. It surrounds the cell. It protects the cell, and it determines what enters in and out of the cell. Okay. Now, on the inside of the cell, we have the nucleus. All right, that's the nucleus. That's the most obvious organelle, right? Is the nucleus.
The nucleus.
Yeah. And then we have inside of it, we have this part here. That's the cytoplasm. Okay, that's a jelly-like material. All right, can y'all see it?
Yes, sir.
Okay.
We can still see it.
Okay. Let me know when to move. All right, let me know when I can move it, please.
You can move it.
Okay. All right. Anyone else? Anyone else second that?
You can move it.
Okay. All right. It's 9:01. So we're gonna end now. For tonight. I know we started science early because late rather because we had to do we had to finish up our math. So we started late. So sorry about that. But I'm not gonna keep you any longer. So have a wonderful night, and I'll see you on tomorrow for Spare Life. Nathan, if you wanna come to class tomorrow to join us for some maths, that's fine. If you want to, that's fine. Okay.
Bye, Mr. Cookie.
All right. Take care.